Hi everyone, welcome to our second flipped video. Today we're going to be taking a look at how do geographers use and interpret maps. And this is part one of that same essential question, which is why I've labeled it as such. You feel free to add in that subtitle that says Map Basics, discussing the structure from last class, from our last flip video. Again, if you're looking in your spiral notebook, you should now have this exact phrasing listed at the top, and most importantly would be the essential question there. And let's go ahead and dive in. Last flip video, we were discussing the evolution of geography as a field of study, and we talked about the role of maps. And today we're going to dive a little bit more specifically into maps, how they are structured, how they're organized, and how geographers use them. So we're going to start off just with a basic understanding that simple observations, so observing the world around us, and maps, those two things are really at the heart of what it means to be a geographer, and those are the tools of a geographer. So that's why maps themselves are so important to us, and both in this course and as geographers ourselves. Just some really basics here. So if this is well beyond you, please forgive me, but I want to make sure we all start on the same page before we start to work into some pretty complex stuff with modern maps. So very, very basics, putting on the left-hand side the term cardinal directions. When people refer to cardinal directions, we're referring to the directions north, south, east, and west. And you can see here as that's listed. You'll notice, of course, that in the middle of northeast would be, or north and east is northeast, south the southeast, so on and so forth. And what you see on the right there on the image is actually what's called a compass rose. And that compass rose, it appears on many maps, not all, but many, to help get oriented on the map. You'll probably are familiar with this if you yourself have used the GPS feature of your maybe of a smartphone. You may have noticed over time that the compass rose actually become increasingly important because there was a time when the map would not orient itself, but now that maps and the GIS technology and the GPS technology has improved, you're able to change the orientation of a map, making cardinal direction that much more important. Talking about lines of measurement. There are many on a map. There are many different ways to measure where a given place is, but the base of all of those, or the basis of all of those, are the lines of measurement of latitude and longitude. You'll see that the latitude, of course, runs east to west or west to east, and longitude runs north to south. And we're going to break down a couple of the key features and the key lines of measurement that you must know, both for this course and in life. So let's begin first with the one that you're probably most familiar with, which would be the equator. And the equator is located at 0 degrees latitude. That's dead in the middle of the Earth. The equator divides the Earth into the northern hemisphere and the southern hemisphere. Hemisphere, I guess you could consider just to be half. So that's our basis here. That's important, that terminology, the northern and southern hemisphere, because we're going to be looking at patterns and trends as it pertains to the northern hemisphere, southern hemisphere, as well as the eastern and west hemispheres, which of course we get from the line of 0 degrees longitude, known as the prime meridian. And that prime meridian runs straight through a town called Greenwich in England, where the earliest geographers developed this prime meridian. And that divides the world then into the western and eastern hemispheres. This picture is a bit confusing, so I want to make sure I clarify that the prime meridian divides west and east. I just included the equator in this as well, but just so we're clear about this being the halves of the world. This also gets just as a helpful terminology, this western hemisphere, because we need to clarify that, because as we start to talk about cultural patterns and economic patterns, we're going to hear people discussing a lot the concept of the West, which seemingly would be a reference to the Western Hemisphere, but it's actually a little bit confusing. It's not. It's a reference to some of the countries that have ways of life that are in common. In this particular instance, it's really referring to the United States, Canada, and some of the Western European countries. So good to know what truly the terminology Western Hemisphere and Eastern Hemisphere refer to. All right, so those are just the basics and the lines that you're probably most familiar with. Geographers use these lines of longitude and latitude in different ways. So let's break down this concept of latitude a bit further. Latitude, let's put this on the left-hand side, as well as the parallels, because lines of latitude are also known as parallels. These lines run. Oh, geez. I'm sorry. I'm going to pause this just for a second. We got a bit of a typo here. My apologies, had a bit of a typo. I'll clarify that. That latitudes, also known as parallels, run east to west on the Earth, as you see in the top right-hand corner. You see those lines that run from east to west. They encompass the Earth. But what the lines of latitudes actually measure, so where they are versus what they measure how far north or south a point is from the equator. Let's see what I mean by that. When you're measuring here, we look at this line of latitude that runs along the Earth. That is actually measuring how far this piece of the Earth, in this instance this is in northern Africa, how far that location is from the equator. So lines of latitude, they run east to west on the Earth, but they are actually measuring how far north or how far south a particular point is from the equator, from 0 degrees latitude. This makes a bit more sense if we look at this map here. If here's our equator, we're measuring with our lines of latitude, east to west, how far north, how far south, right? So 90 degrees south latitude is it means that this point is 90 degrees south of the equator. Just another way to look at that here is if you're looking at lines of latitude, we're measuring here again how far north or how far south something is from the equator. Now let's change that here for lines of longitude. Lines of longitude are also known as meridians. That's an easy thing to remember if we remember that the prime meridian is located at 0 degrees longitude and it runs north to south. Now here, as I just said, the lines of longitude run from north to south on the Earth. Of course, they meet at the poles, as you see here. They run north to south, but they measure how far east or west a point is from the prime meridian. Let's go through here and let's look at that again. If we're going back to this map right here, if we have our lines of longitude, then we are measuring how far west or east. Here's the prime meridian, there's a better one. Here's 0 degrees longitude. Our lines of longitude are measuring how far east or how far west a given point is from the prime meridian. And I'm saying this and I'm repeating this point simply because it is counterintuitive. If it's running north to south but measuring east to west, or it's running east to west but measuring north to south, it's important that we understand and we have a visualization of what those lines of longitude and latitude actually are. A couple other key points, a couple other key lines that are just good to know, lines of measurement that are important in several of our discussions, agriculture being an important one that comes to mind. There are two lines that are located approximately 23.5 degrees north latitude and 23.5 degrees south latitude. These lines are known as the Tropic of Cancer and the Tropic of Capricorn. I'm going to give you the formal definition and then we're going to talk about a little bit more common understanding. Formal definitions, we've got the term Tropic of Cancer on the left. On the right, we have the circle of latitude on the Earth that marks the most northerly point at which the sun may appear directly overhead at the June solstice. I'm going to give you the definition for Tropic of Capricorn, and then we'll actually break it down and understand what that means. Tropic of Capricorn is the circle of latitude on the Earth that marks the southerly latitude at which the sun can be directly overhead at the December solstice. If you notice on the graphic, 23.5 degrees north, 23.5 degrees south latitude, that comprises an area of the world that's known as the equatorial zone. It's the area of the world that is considered to be the low latitudes, because that makes perfect sense. We're speaking mathematically. 0, 1, 2, 3, all the way up to 23.5, and 1, 2, 3 all the way down for 23.5 degrees south latitude. That zone around the Earth is called the equatorial zone. Now let's take these definitions about the most northerly point at which the sun may appear and the southerly point. To better explain that, I'm going to show you two things. I'm going to show you this graphic here. First, it's important for us, actually, let me see if this comes, no, okay. First, it's important for us to understand, please do not ever tell someone that the seasons happen because of the distance the Earth is from the sun. We're not closer to the sun during summer and farther from the sun during winter. That's not it at all. Rather, the axis of the Earth is constantly spinning on its axis, as you see in this map here, or this graphic here. There are certain points at which the Earth is more directly experiencing sunlight versus indirectly experiencing sunlight. That is not the case in the equatorial zone, in that the equatorial zone is almost always receiving direct sunlight. And let me pull up a quick YouTube clip to illustrate this. And here it is.
The Earth travels around the Sun. It takes 1 year, for the Earth to go all the way around the Sun one time. And because the Earth is tilted, sort of like a spinning top, parts of the Earth get more heat and light from the Sun at different times of the year. You see? Spring, and summer, fall, and winter.
Really quick clip, just as you saw there. Point being for that, the explanation of that, is that the Earth, there's different points at which the Earth more or less directly hits the Earth. You'll notice, as it was mentioning here, that if the Sun is more directly hitting the Earth's surface, then the temperatures will be warmer. If the Earth is experiencing on its axis and it's not as directly hitting the Earth's surface, then that area is going to be experiencing winter. The equatorial zone, to bring this all back together, the equatorial zone is going to almost always experience direct sunlight, and that Tropic of Cancer and Tropic of Capricorn are measurements at the latitude at which the sun most directly appears overhead. So they're experiencing the most direct sunlight during the June and December solstice. Lots of information to ultimately make the point that that is the zone of the Earth, the low latitudes, the equatorial zone, is the area of the Earth that most directly experiences sunlight, and therefore, of course, is the warmest. Coming back to our discussion of latitude and longitude. Just key points that we need to know, of course, so that the North Pole is at 90 degrees north. It's the northernmost point on Earth. It's found in the Arctic Ocean. Bottom left, you see, you can follow with you can follow along here if you're looking at 90 degrees north latitude. You see right there, that's up in the Arctic Ocean. If we were looking at what's known as an azothermal map, we'll talk about that in the coming days, and we're looking at a specific point on the Earth, you'll notice you see right in the Arctic Circle, and you can see where the North Pole is located. In contrast, we have the South Pole. The South Pole would be the southernmost point on Earth's surface. If you can follow again on the left, you can go all the way down to 0 degrees latitude, and we have the South Pole. The map on the left, of course, would make you believe that Antarctica is enormous when it's not nearly as large as it appears in this map, and we'll talk about why that's the case when we talk about projections. If you look on the right-hand side, you can see a far more accurate depiction of the size of Antarctica. What you see there at 90 degrees south latitude, we have the South Pole. Couple pieces of terminology. So what do we use these for? How do geographers use these different lines of longitude and latitude? Well, one of the ways, of course, is what's known as absolute location. So geographers use lines of longitude and latitude to describe the exact position of a place on Earth's surface. So the term absolute location is the term that is the description of the exact position of a point, often using lines of latitude and longitude. Here's an example of absolute location. Kenya's latitude and longitude is 1 degree north and 38 degrees east. That is, Kenya is 1 degree north of the equator and 38 degrees east of the prime meridian. So you can see where the equator falls here. In that description, you see how Kenya, at this point in Kenya's surface anyway, or Kenya's area anyway, would be 1 degree north and 38 degrees east of the prime meridian. That's known as absolute location. And that's not the only way that geographers use maps. They also use the maps to describe the relative location of a person, place, or thing. Relative location, I'm going to read you the definition and then we'll break it down. It finds the location of something using surrounding places or by cardinal directions. Here's what I mean. Kenya is south of Ethiopia, north of Tanzania, east of Uganda, and west of Somalia and the Indian Ocean. That doesn't tell you exactly where it is. It tells you where it is in relation to other places. Let's try a different one. Mexico is south of the United States, is west of Venezuela, is north of Panama, and is east of China. Right? So that's going to tell you the relative location of Mexico using other points. You can keep doing a much smaller scale. You probably often give directions this way to a place if you don't know a street name. Oh, it's that McDonald's it's at the end of the hill, south of McKinley, right? East, maybe don't use east and west, but you could, right? The McDonald's that's close to the Wendy's, that is across from the ATF, the area down there right by the metro. So that's the idea of how you describe something using relative location. Another way to use these lines of longitude and latitude are through time zones. Time zones are actually quite simply dividing the Earth in zones of 15 degrees longitude. So if the Earth is divided, if it takes the Earth, I'm going to just do this real quickly here. If it takes the Earth is 360 degrees, right? It's a sphere. If the Earth is rotating in 15 degrees of longitude, each one of those 15 degrees corresponds to an hour. It takes 15 times 24 for the Earth to make a full rotation. Right? So if we divide that full rotation, 360 degrees, we divide it by 24, we get 15 degrees of longitude. In other words, each time zone corresponds to 1 hour around the Earth's turn. One turn of the axis completes a day. Here's what I mean. So we took that round Earth and we flattened it here for this next step. And you can see that these time zones are separated by 15 degrees of longitude or meridians. Each one of these time zones is based upon that same prime meridian, right? That prime meridian of 0 degrees longitude, the time essentially starts there. It's a silly way to say it, but Greenwich Mean Time is the time at the prime meridian. Remember I mentioned that the prime meridian runs through Greenwich, England? Well, that's 0 right there, 0 degrees longitude. If we go 15 degrees east, I'm going to use the pointer here. 15 degrees east, we've gone forward 1 hour. 30 degrees east, forward 2 hours. 45 degrees east, we've gone forward 3 hours. And then let's do the other way. If we went 15 degrees west, we've gone back an hour. 30 degrees west, we've gone back 2 hours. 45 degrees east, we've gone back 3 hours. And when I say go back, I need you to simply envision the same spinning Earth again, right? Here's that. Let me pause. Can we do that? If we can pause this here, then you'd see that this is the that right here, right as we go around, there's North America, there's China, right there is 0 degrees. There's that prime meridian, right? And this is going, see how we're going forward? Here's the day, right? And then we'll catch up to a new day. We'll have that one full rotation corresponding to a day. So as the Earth turns, each one of those 15-degree rotations corresponds to 1 hour. Something you may have noticed right away is that these lines aren't straight. Time zones aren't straight. This isn't an even time zone. Check out this one out here. The international date line, where the difference between one day and another. Remember, the Earth is round, so what's happening here at 0 degrees longitude is happening on the other side. Pretend like if you have your hands, actually I'm going to show you this visually so we can make sure we have this down. If you have your hands like this, if this is a flat map, right, that this, if my fingers where they meet are the prime meridian, then remember the Earth is round. So where my thumbs are touching is going to be the international date line. There's the Earth, right, looking more like a heart than a circle. But if here's the Earth, let's flatten it out. There's our map. Here our fingers are touching. That's going to be 0 degrees longitude, the prime meridian. Other side of the Earth is the international date line at 180 degrees. That's the difference between one day and the next. So let's go back here. That's not the, as I said before, this line is clearly not a straight line, but it's representative of trying to keep countries together and trying to make sure that certain countries stay on one time zone versus another. So that's another way in which geographers use and interpret these maps, because they use them to create time zones. And as you noted here, if you go forward to the east of the prime meridian, you're going earlier. Later in the prime meridian, or west of the prime meridian, is later in time, which makes sense when you think about that we experience the international date line. Remember, use it, make that same motion with your hands. If you think about China experiencing these areas experiencing New Year's Eve first, I don't know if you've ever done that before. Watched New Year's Eve all around the world as the world turns. You can see different time zones experienced there. Okay. Another key feature that geographers use and interpret on maps is scale. We have two key differences and two key definitions of this term scale. We're going to go with the easy one and the one you're probably more familiar with first. The first definition I want you to put on the left-hand side is map scale. Map scale is the relationship between how big something is on a map and its actual size on Earth. This is very logical, and it requires very little explanation. The map on the left here, that is not the size of Nigeria, clearly, right? That's not the size of any of the countries that are pictured here. That's not it. Instead, what we're looking at is we're looking at a representation, a scaled down version, right? So as you see, my arrow is pointing. Each inch or so here on this map corresponds to 200 miles. 1 inch on the map versus 200 miles in the real world. That's its scale. That's the difference between the map, the map, and what something is in real life. Now, here's where the AP exam and just sometimes geography in general can kind of try to trip you up. The smaller a map is, the larger the scale. The smaller the area shown on the map, the larger the scale. Here's what I mean. I want you to consider, I'm going to have to show you again so that we can work through this together. Okay, if you take your fingers to the two L's, turn them, so you have essentially like a magnifying glass. If this is the real world, right, you and I are here, this is the world itself. If we have a world map, we only have to zoom in just a bit in order to depict the whole world. We have a small scale. Here's the actual world, here's a world map. If we had a city map, and if this is the whole world, and we're depicting a city, we have to zoom all the way in. Think about the difference between how far your arms move. If this is the real world and this is a world map, world map, then you just moved in a little bit. If this is the real world and this is a city map or a neighborhood map, you had to scale way, 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 way down in order to create that map. So the difference between that map itself and the real world is huge. Let's look at that as it's represented here. Here's a map of Atlanta, first of the United States, where 1 inch corresponds to 940 kilometers, or 1 centimeter. I'm sorry, 1 inch corresponds to 94,000 miles, right? Then we have 94 million miles. Then we have here the 94. Oh, okay, I see what they did. 1 inch corresponds. So that you see here that the representative fraction between the country, the actual country, and what it's depicted on is the map. If you zoom that all the way down to the actual city of Atlanta, then you see that it's going to take that how enormous the difference is here and how a large scale on the map that we have. We have to zoom way, way, way in order to depict that map as it's represented in the real world. So the smaller the map, the smaller what it's showing, the larger the actual scale. There are different ways to depict that scale. This is very, very straightforward. You can depict it as a ratio, so 1 inch is to 24,000 miles, or a fraction, 1 inch is to 100 miles. You could do it graphically, and you show how far something is, and you say that that's 100 kilometers. Or you could just write it out, 1 inch equals 1 mile. There's all different ways that geographers describe and cartographers describe the difference between what's shown on the map and what's shown in the real world. Okay, here are your analysis questions. There are 5 here. We're going to set these up exactly as you did for the last flip video. I'd like the title of what you're going to turn into me to be the exact same thing that you wrote for your map, for your notes itself. You'll note for number 2 that you need to actually go to this link. You're welcome to, you can't copy and paste it from this video, so you can either copy this down or the link is